factoring polynomials, factor completely. Even if your instructions do not say factor completely, and they just say factor, then you really need to make sure that your problem is factored completely. Now, what does that mean? That means, number one, let me write this down. I'll write it above it. So if polynomials are factored completely, number one, there's no greatest common factor. You've taken it out. You don't have a difference of squares. You don't, or difference of cubes, or sum of cubes, which you'll learn about that later. Any trinomial that you have has been completely factored. All of those things have to be true. So let's look at each problem. The first thing I'm going to check for is a greatest common factor. Do these two terms, this is a binomial because I have a subtraction sign between two terms that have multiplication with them, and then do they have a common factor? A numerical common factor, yes, and a variable common factor, yes. So my common factor here is 10x squared. If you don't know how to find the common factor, I want to show you really quickly. First of all, for your variables, you choose the variable that has the smallest exponent. Both of these have x squared, so that's where that came from. But where did 10 come from? If you write down all the factors of 10, which those are all the factors of 10, and all the factors of 40, and what's the greatest common factor they have in common? 10 is the greatest common factor they have in common. So that's how you'd find the greatest common factor if you don't know just by looking at it. Okay, now I'm going to divide both of those terms by 10x squared. Okay, so 10x to the fourth divided by 10x squared is x squared. 40x squared divided by 10x squared, negative 4. Now, most students would stop, say they're finished, but you've got to check this binomial. Can you factor this binomial again? Look for patterns that we've discussed in the past. Yes, this is a difference of two perfect squares. So I know I need to keep going, bring down my greatest common factor. It has to always be included. This is a difference of squares, so I put two empty binomials, one with an addition sign, one with a subtraction sign, and I take the square root of x squared. That answer goes in the first spot. And I take the square root of 4. That answer goes in the second spot. And then check your binomials again. Do you have a difference of squares here? First of all, there aren't squares. And second of all, that's a plus sign. I do have a difference here, but these aren't squares, so I know I'm finished. This is the answer to number 1, factored completely. Let's look at number 2. Number 2, I have a binomial very similar to that one. My advice would be to pause the video and try number 2. Number 2 is very similar to number 1. Don't just watch it. Be an active participant in doing these problems, because that's how you're going to know how to do them when you work assignments or take tests with these particular problems in them. Okay, so as I look at this one, they both have 4 in common, and they both have x squared. And you could do each step as I go along. You could take out the greatest common factor, play, and see if you got it correct. 4x to the fourth divided by 4x squared is x squared. Negative 16x squared divided by 4x squared is negative 4. And look at that. Look at this, and look at that. We have the same thing. I know that's a difference of squares, so I'd bring down my greatest common factor, put 2 empty binomials, take this square root, I'll put an addition sign and a subtraction sign, take the square root of x squared, and take the square root of 4. And now I have factored number 2 completely. Let's look at number 3. Okay, looking at number 3, Do I have a greatest common factor? No, I do not. Okay, next, I have a trinomial. Okay, I have a trinomial. I have a is 3 in my trinomial, and it is a trinomial in the form to be factored. This exponent is half of this, so I can factor this. Okay, I need factors of a times c, so factors of negative 15, that will give me a sum of negative 14. Looking at this, I know I want two things that multiply to give me a negative, so that means I need a positive and a negative. I want a negative sum, so my bigger number is going to be negative. That's it, isn't it? And this is the one that works. Negative 15 times 1. So I'm going to put two empty binomials. I'm going to put my middle variable of x. I'm going to put minus 15 and plus 1. Now, if you've watched my other videos, a is not 1 here, so hopefully you recognize that I'm choosing to do bottoms up. I'm going to divide each factor that I just put there by the a value. 15 divided by 3 comes out perfectly as 5. 1/3 won't reduce, so this is where I do bottoms up. I take the denominator up here beside the variable of x, and so that would be 3x plus 1. And then check to see, I have two binomials here. Can this binomial be factored? Nope, I have a difference, but these aren't perfect squares. And this is not a difference, so that one is completely factored. That is my answer to number 3. And on to number 4. Looking at number 4, I have a trinomial. I have a common factor. They're all divisible by 2. So I'm going to move my camera. Going to divide each of those by 2. 2h to the 4th divided by 2 would just be h to the 4th. Negative 6h squared divided by 2 would be negative 3h squared. And negative 8 divided by 2 would be negative 4. Okay, now I still have a trinomial. A is 1, B is negative 3, and C is negative 4. I need factors of A times C, so factors of negative 4. That will give me a sum of negative 3. And that would be negative 4 times 1. Bring down that greatest common factor. Don't forget to keep it with you. Use your middle variable, h squared, minus 4 plus 1. Okay, now, I remember I need to factor completely. Is this factored completely? No, this is a difference of two perfect squares. Bring down your greatest common factor, put two empty binomials, one with a plus sign, one with a minus sign. Take the square root of h squared, that's h. Take the square root of 4, that's 2. And then, can this be factored again? Students will factor it, so be careful. But I have, both of these are perfect squares, but I don't have a subtraction. So I need to bring that down here. That is my answer to number 4. And I have one more to go. And hopefully you notice I have 4 terms this time. Do all 4 of these terms have a common factor? No. How do I factor 4 or more terms? I use grouping, which means you put parentheses around them. Oops. I want a plus sign in the middle. Okay, my first group, what do they have in common? Numerically, they have 3 in common. Variably, they both have an m to the first power. Divide by 3m, n squared is left. Divide by 3m, minus 16 is left. Bring down, oh, I don't need to bring down my plus sign. On the next one, this is a negative number, so it doesn't matter if both of them are negative. I have to bring out a negative greatest common factor, so there's going to be a minus sign there. What do they have in common? 2. They don't have a variable in common. Now I'm going to divide both of them by negative 2. Negative 2n squared divided by negative 2 is n squared. Positive 32 divided by negative 2 is negative 16. Okay, now, my binomial that I have left, do they have a common factor? Yes, they do. They have those in common. So I can bring down n squared minus 16. And what's left when I take out the common factor? 3m minus 2. And then most people would be finished. They would be done. They'd circle the answer and move on. But these are binomials. Is this binomial factored completely? Is this binomial factored completely? One of them, the answer is yes, and the other one, the answer is no. Which one? This one is yes. 3m minus 2, that's done. I have a subtraction sign, but I don't have perfect squares, so that's finished. N squared minus 16, I have a difference of 2 perfect squares. So I can bring down 2 empty binomials, one with an addition sign, one with a subtraction sign, take the square root of n squared, that would be n, take the square root of 16, and that would be 4. Now I need to check again. Do I have a difference of 2 perfect squares? Well, this is a perfect square, that one's not, and that's not a difference. I do have a difference, and this is a perfect square, but that's not a perfect square, so I am finished. This is my answer to number 5. My advice is, if you struggle with this factoring, is to rewatch the video, write down the question, pause the video, try it yourself, and then watch it to see if you did it correctly. Factoring is just something you have to do over and over until it finally sinks in and it becomes relatively easy.